Today we're going to talk about carbon as the basis of life's molecules. You've probably heard the phrase carbon-based life form if you've watched any sci-fi. And there's a lot to that. The properties of carbon as an element, as an atom, are very important to how biological molecules fit together. The diversity of molecules within a cell are composed of carbon bonded to other carbons or other atoms or elements. We often talk about a carbon skeleton or a carbon backbone. We're going to look more closely at that through this lecture. Carbon-based molecules are called organic compounds. Those of you who will be going on to take organic chemistry will spend an entire year talking about organic compounds, how they are made, and how they interact with each other. So here's a very, very simple carbon-based molecule. It's methane, CH4. By sharing electrons, carbon can bond to 4 other atoms and form a variety of carbon backbones. For the purpose of this lecture, you want to think of backbone and skeleton as sort of the same thing. So when we refer to the carbon skeleton, it's the same thing as the carbon backbone. Methane is one of the simplest organic compounds. It's also a big source of polarity at my house. So it's 4 covalent bonds linking hydrogen atoms to a carbon atom. Each of the 4 lines in the diagram represents a bond. And we talked about in Chapter 2 what the solid line means when we're representing chemical bonds. So a solid line tells us that the bond between carbon and hydrogen is a covalent bond. If you look at carbon on the periodic table, it'll show you that carbon can form 4 bonds. So take a moment, pause the tape, we'll say that, go look at carbon on the periodic table. You'll see that it's missing 4 electrons to form a full outer shell. So that's why it can form 4 bonds. With those 4 bonds, carbon fills its outer shell. So carbon can form bonds with a variety of atoms. Here's a carbon atom. You can see here on the left. It's got 6 protons, 6 neutrons, and 6 electrons. You can see the 2 electrons in the inner shell and the 4 electrons in the outer shell. And we talked about in Chapter 2 that a full outer shell would be 8. So this is why we can form 1, 2, 3, 4 bonds. So in this case, carbon has formed bonds with hydrogen, 4 hydrogens, and we get methane. So the chemical formula for methane would be CH4. Something you want to make sure that you keep reminding of yourself what a chemical formula means. There are multiple ways that we can characterize carbon skeletons or carbon backbones. The first and most simple way would be length. So at the top you can see an example of 2 different carbon skeletons. This one has 2 carbon atoms at the heart of it, and this one has 3 carbon atoms at the heart of it. So the length of the carbon skeleton is a way that we characterize carbon-based molecules. Another way that we characterize them is, are they branched or are they straight? On the left, you see an example of butane. That's a straight carbon skeleton or carbon backbone. On the right, we see isobutane, and this one is branched. We have 3 carbons in a row, and then the center carbon branches up to another carbon. So another way to characterize a carbon-based molecule is whether it's straight or branched. The third thing we look at when we're characterizing these carbon-based molecules or organic molecules is the type of bonding that's involved. Do they have double bonds or do they have single bonds? So if you look at butene on the left, you'll see a single bond between these 2 carbons, a single bond between these 2 carbons, and a double bond between these 2 carbons. Whether or not double bonds are present affects how that molecule behaves, and where they are affects how that molecule behaves. So that's another thing we look at, and you'll look more closely in organic chemistry. The last thing that we look at to characterize carbon skeletons is whether or not the carbon skeleton forms a ring. So at the bottom you'll see cyclohexane and benzene. So these carbons arrange themselves into a ring form. And you can see this one has some double bonds, this one has only single bonds. So looking at those, you can see that these carbon-based molecules form a ring. A hydrocarbon is just an organic molecule made up of hydrogen and carbon. It's nice because hydrocarbon, hydrogen and carbon. Many organic molecules, like fats, have hydrocarbon components. So this is a really important type of carbon-based molecule. And we'll talk more about fats later on in this chapter. One of the major characteristics of hydrocarbons is that they can undergo reactions to release a large amount of energy. I have some examples of hydrocarbons over here on the left. Again, remember, you don't have to memorize examples. These are just to help you understand what we're thinking about. You can see methane, ethane, propane, butane, and pentane. Most of you have probably heard of butane or propane, right? Propane grill, a butane torch. These are things that are flammable and release a lot of energy when they're burned. So we're familiar with hydrocarbons and their flammability and their ability to release a large amount of energy. And we'll stop there. We'll come back to functional groups